In today's class, we will be solving a few problem sums based on expressions and special products which are of level 1. So let's get started. The first one we need to simplify, and for that what we'll do, we know many identities, and one of them is when we have x plus y multiplied by x minus y, that is equal to x square minus y square, that we know. Now, if suppose root a that we take as x and root b that we take as y, then root a plus root b multiplied by root a minus root b, that can be written as, that means that will be equal to x square minus y square, so it will be a minus b. So in this expression we can write a plus b then multiplied by a minus b. We have these two factors, so again we will use this identity, so it will be finally a square minus b square. Now in the second question we need to find the degree of the polynomial which is given. So if we expand this polynomial using the identity that we know, so as per this identity it will be x square is here a, so it will be x square whole square, then minus 2a, and then b is x, then plus b square, so it will be x is b here, so x square, so finally it will be x to the power 4 minus 2x cube plus x square. And this is a polynomial of x where the highest power of x is 4, and we know the degree of a polynomial of one variable is the highest power of that exponent of that variable. So here the degree of this polynomial will be 4. Now the next question says that by using an appropriate identity, find the following. So here we have 10 and 1 by 4, and then square value of that can be represented as 10 plus 1 by 4 and then whole square of that, and that is actually that resembles this identity. So here it will be 10 square means 100, and then plus 2ab, 2 then 10 is a, and 1 by 4 is our b, and then b square means 1 by 4 square value, so it will be 100 plus 5, and then 1 by 4 we know that is 0.25, and square value of that will be finally 0.0625. so here it will be 0.0625, and when we will sum them up, these three terms, it will be 105, and then after decimal point we have 0.625. Now in the next question again we need to use an appropriate identity to find the following. So in this type of problem what we can do is one way is we can find the difference of the given two values. So here 111 and here it is 89, so it will be 22, and then that will be divided in equal parts, so that will be divided by 2, so finally it will be 11, and then we will add that value, here it is 11, to the smallest value in that expression that we have. So that was 89, so 89 plus 11 it will be 100, and the same value 11 we will be subtracting from the highest value that we have in that expression, so it will be 100. That means in both the cases the value that we are getting is 100, and that is same, so that will be taken as base value or reference value, and the other two values which are given in that expression will be represented with respect to that values. Now it resembles one of the identities that we know, and what is that? So it will be 100 square and then minus b square. B is what? B is 11, so it will be 100 and then two more zeros as we are finding the square value, and then it will be 121. It will be 9879. Now in the next question we need to find the HCF of the following two values which are given in the form of x, y, z, these three variables. So 26 x square, y square, z square, 2 multiplied by 13, and then the second term, so 39, 3 13s are 39. So here we are finding highest common factor. So what are the common values that we have between these two values that we need to first identify? So here we have 13, here we have 13. These are the common values. So 13. Then between these two values in terms of x, the first variable, here we have power 2, here we have power 3. That means x square will be common between these two values or terms. So x square. Then between these two values in terms of y, the second variable, here both the powers are or exponents are 2. So the common values will be y square, and between these two values, the third variable when we consider, which is z, the highest common exponent for z is 1. So it is z, and that will be the HCA value which is given in this question. Now in the next question we have this expression and we need to factorize. And when we need to factorize them, first we have to identify or find that whether we have any common factor or not. In both these terms we have one common factor, which is a minus b. So that will be taken as a common factor, and then rest of the terms will be written. So rest of the terms means from the first term it will be 3x plus 2y, and from the second term what is remaining is 3x minus 2y. A minus b will be written as it was, and then we will simplify this. Plus 2y and minus 2y will cancel each other, and what will remain in this factor or term is 6x. Finally this value will be 6x and then a minus b. Now in the next question we have to check whether the following is a perfect square or not. So let's write that expression first. So we have two square terms here. We have 4x square, that can be written as 2x then whole square. Then we have 8y square, that can be written as root 8 then y and then whole square. And then if we use that identity a plus b whole square, now let's see whether we can represent the given expression as per this pattern or not. Now the given expression, if it matches with this pattern a plus b whole square, then 16xy has to match with this term 2ab. So let's check that. So 2 and then a is our 2x and b is our root 8y. But when we multiply these terms, here we have 4 and here we have root 8. So it will be 4 root 8. So that means this value finally is coming as 8 root 2 xy, which is not matching with the given term in terms of xy, that is 16xy. So this cannot be, the given expression cannot be represented as a perfect square. And if it was a perfect square, then this would have been 2x square, that is fine. And 16xy, this would have been 2 then 2x, so 4x, and still we have 4y here, so it will be 4y. So 2 multiplied by 2, 4 multiplied by 4, it will be 16, and then xy. So 16xy is okay, that is matching. Then 4x square is also okay, and the second term, which is actually in the form of b square, that would have been then whole square of 4y, that will be 16y square. So in the given expression, if in place of 8y square, if it was 16y square, then we would have expressed that expression as a perfect square, and then that would have been written as 2x plus 4y and then whole square. Now in the next question we have the division, where the dividend is x square plus 6x plus 8 and the divisor is x plus 2. Now we know in this type of division what we do is first we factorize the dividend. So now between these two terms, the common term is, or common value is x, so it will be x, and then the other factor will be x plus 2. And between these two terms, third and fourth term, again the common value is 4, and then the second factor will be x plus 2, and in the denominator we already have x plus 2. So in the numerator now the factors will be x plus 2, which is the common factor, and the second factor will be x plus 4. and in the denominator again we have x plus 2. So what I can see here is that x plus 2 is the common factor between numerator and denominator, so they will cancel each other. So the quotient value of this type of division, or particularly of this division, will be x plus 4. Now in the next question we have the simplification. 256 we know that is square value of 16 and a to the power 4, so that can be written as square of a square, and then again b to the power 4, so that again can be written as square of b square. And in the denominator we have 625, so 625 means it will be 625 can be expressed as square of 25, then we have a square, and then we have b square. So when it will come out of the square root, or when we will take the square root value, we will consider all these individual values. Now we can simplify further. Between 16 and 25 there is no common factor, so they cannot be simplified further. But between a square and a, what we can do is 16 divided by 25 and a square, so a is the base and power here 2, and we are dividing by a, so it will be 2 minus 1. We know that rule. And then with the next variable is b, again here we have square 2, and in the denominator we have 1, so we are dividing, so it will be again 2 minus 1, so final value will be. Now in the next question, which is the last question of this class, we have these four terms: x cube, then we have minus x square y, then we have xy square, and then we have minus y cube, and we need to factorize this given expression. So between this first and second term we have x square common, so this in the second factor we will have x, and here we will have minus y, so it will be x cube minus x square y. And between third and fourth term, if we analyze, then we can see y square is the common term. So if y square we take as common, then the other terms which we'll have within the bracket will be x and then minus y. So here what you can see is x minus y is the common factor, and in the second factor we will have x square from here, and from the second term we will have y square. So this will be the final answer. So I hope this class was meaningful for you. In the next class, we will be solving a few more important problem sums. Till then, stay safe and stay healthy. Thank you.